Yeah, oh, yeah, I saw that.
Oh, well, twins.
That's the one I saw too.
We did 35 in class, didn't we?
I think we started it.
All right, find an equation for the line tangent to the graph at the point, and they gave us the point. That was mighty nice of them. So let's do the derivative first. What's derivative of tangent? I hope y'all know this by now. Secant squared. So find the derivative at that point. Secant is 1 over cosine, yes? What's the cosine of pi over 4? 2. You're close. Square root of 2 over 2, that's right. Square root of 2 over 2 squared. Yo, you don't need A?
I do. I need all around.
Is that not right? So then that's my slope. So y minus 1 equals slope times x minus pi over 4. Because I secant. That's what secant is. Because I know what secant is. Did y'all know to change that to 1 over cosine? Part B, find an equation for the line tangent to the graph of inverse tangent. Are y'all good with that? I see, I've never really seen why, I think Madison, you said all the tangents get confused. I don't know why it never dawned on me. We've got the tangent function, and then we find a tangent line. Oh, was that Sophia? Okay. Yeah, and I'm seeing it now. All right, so same song and dance, but just backwards. So derivative, inverse tangent, that one I don't know off the top of my head. 1 over 1 plus x squared. So I'm going to do that at 1. One plus 1 squared, which is 1/2. And they gave me this point that was mighty nice of them because I don't have to plug in to find anything. So y minus pi over 4 equals 1/2 times x minus. Which one? Yeah, this was a different equation. This was part B defined it. This was all given to me.
Plug into X, and why did you plug in pi over 4 for the last?
There's a whole other problem. It said write the equation of the tan line. Y'all okay there? If we've only got one more section left, we're gonna start it today. So what's today? Wednesday? It'll be next week.
No, like Thursday.
Depends on how long it takes to bring myself to put my contacts in. Don't have it in me. Oh, I'm just tired of them. They make my eyes, especially when I don't feel well, they already. They just. What else on your homework? 36B. Okay, to do 36B, I think we need to address 36A. X to the 5th plus 2x cubed. Did y'all watch Verge last night? Oh, man. I love Verge.
Yeah, her best friend. Probably.
No, she's one of the readers. She and Mark. No. And they put together a lot of their college board pays them to put together a lot of stuff, but they're two of the top readers. The ed exam. Huh? Yeah. But I follow some of their Facebook stuff. All right. So it says find first for part A, find f of 1, and then it says find f prime of 1. So f of 1 is easy enough, right? I know y'all didn't need A, but I'm going to do A anyway. 1 plus 2 plus 1 minus 1 would be 3. F prime of 1, so derivative would be 5x to the 4th plus 6x squared plus 1, so that'd be 5 plus 6 plus 1, 12. All right? All right, so then part B. Find the inverse 3. I'm going to show you in just a minute. All right, what's the inverse here? 1. Why is it 1? Because of part A, because this means switch x and y, right? So in the original one, when y is 3, what is x? We just did that. Inverse switches x and y, right? This is saying that this has the point 1, 3. Well, if I switch x and y and then I let x be 3, what is y going to be? Negative 1. Yes. Because if this is f of x, right? And the point here is 1, 3. Then if I do the inverse of f of x, it's 3, 1. So that's what this is asking me come on. This is saying, what is the inverse at 3? Well, the inverse at 3 is 1. Now it, because of that negative 1. Then the second one is, so the second one says the inverse, right, the inverse of the derivative at 3. So think about this. Right? We already know that the inverse at 3, the inverse at 3 is 1. Right? So what is the inverse? Is it should be, wait, what did it ask? Yeah. How'd you get 1 over 12? What'd you do? Right, so you do 1 over f prime. Well, if 3 is b, what is a? Well, I come back to this first one. A was 1. So, and we just did f prime of 1 in this part, so it's 1 over 12. Yeah.
Oh, that is. I don't know.
Okay, so it asked for this, and then it asked for, I don't think it put, yeah, it did put the 3. And it asked me. Wait, yeah, it did. No, you're on 37.
No, you got one of the
Okay, so, but really all we're doing, so switch x and y, and then do 1 over the derivative of that new x value. Does that make sense? No, that doesn't make sense.
Yeah, you got it.
I got it, but do you got it?
Yeah, I know what's going on.
Which other one? Didn't we do 37 together? I feel like I should show y'all Verge's little video. I feel like it really would help if y'all didn't watch it. Come on. 45. Derivative of the inverse. Did you change it? Times 1/2. That's right. So the derivative of inverse sine is what? One. And then chain it. So as I look at 45, I need to make sure that my answers are kind of formatted the way that these are. So I'm going to go through. Let's see. We just combined here. 1 minus x squared over 4. Oh, I see what they did. So if you look at how their answers are formatted, I need to think about how in the world can I rewrite this to where it'll look similar, because all their answers are, the bottoms are all the same, right? Square root of 4 minus x squared. So my question is, how can I force the bottom to look like that? How can I force the bottom to look like 4 minus x squared? Make it 4 over 4.
Oh, multiply by 4.
I can't change the value though. What happens if you factor out a 1/4 to get this x squared by itself? You could. I factored out a 1/4 whenever I did it, but it's kind of the same. It comes out. I'll do it both ways. Let me show you both ways. I'll do it the way they're saying. So they said they had a common denominator. So 4 over 4 minus x squared over 4, which is 4 minus x squared over 4. Just common denominator. I just came over to the side. So this is square root of 4 minus x squared over 2. Right? And because I got this 2 already on the outside, I end up with 1 over square root of 4 minus x squared. What 1 and 2? No, when I worked through this one, I factored out a 1/4. Just because x squared was over 4, and I said if I take out a 1/4, that leaves me with 4, because if you factor it out, you got to divide if I divide by a fourth, right? will that get me back to where I started? Yes. And if all this is under the square root, well, what's the square root of 1/4? 1/2. So either way would work. Depends on how you see it. What else on those? Y'all okay? Y'all ready to differentiate some logs? You'll like these. Let's do it. Uh-oh. What? Yeah. We'll probably have to get another notebook. Maybe not. Oh, yeah, you're right. Let me give you the two. Let's do E first. These are fun. You just have to remember to chain it.
Oh, that clearly.
Why in the what?
I don't know how I got this.
I didn't give them back to you? And they're just quizzes? I'll hand them back to you then. When I got them. Derivative of E is just E. Why am I including E with logs? It's the base of a natural log. That's exactly right. So now that we're talking about natural logs, these, by the way, are all on your hot pink sheet. The derivative of the natural log of x is 1/x. These are the two most common that will pop up all the stinking time. You'll see them all the time. Yes. But you got to remember to chain it. You want me to derive it and show you how it works? Or do you want to? The other two do not pop up quite as much, but we include them in this section. Derivative of a value raised to the x is going to be exactly the same thing, but then you multiply it by the natural log of a. These are like if it was 5, if f of x was 5 to the x, then the derivative here would be 5 to the x times the natural log of 5. Unless, of course, that x had something with it that I had to chain it. And then everybody's favorite. The derivative of a regular old log with some base here that's not e is going to be 1/x times 1/the natural log of the base. Not quite as common. Most of the time you're going to have natural log that you're taking the derivative. You ready to do some? These are just plug and chugs, memorize. I like this day. Y'all won't like tomorrow as much. That's okay. Yeah, you will. I'm going to work through some of the homeworks with you because it does look like a lot, but it's really not. You'll see as we start going through. It's not as much as you think. Let's do number 9. No. Find dy dx. This is page 193. No, they're bright ones. You always change, it always follows with a dx, whatever the derivative of the x part of the function up there, yeah. So I keep the E part the same, right? And now I'm going to do the derivative. This is where my chain comes in, the derivative of this, right? What's the derivative of the square root of x? Right? With me? So I can clean it up a little bit. Y'all okay if I do that? That's it. Told you. Break them up in separate pieces and go straight across the top and straight across the bottom. I'm sorry. I didn't mean to be evil. What's that? Robert, this was for you. Okay, do it. Y'all don't tell them the answer. You didn't chain it. Did you chain it? Why would you chain it? All right, y'all are right on this part. Yes. Yes. Gotta chain it. Okay, because this is a whole function. It's not just x, right? Think about always chaining it anyway. And if it's just x, you're going to multiply by 1. So you're really chaining anyway.
But how do you know that whenever
I haven't cleaned it up yet. I'm fixing to. Say again, Robert?
like I want to see how you know that whenever
Well, if I do power and then subtract 1.
no, not that ln.
This is the derivative of ln. This is my chain.
Are you not doing the derivative of ln over x?
Yeah. And you tried to do quotient on it? If you would have to do quotient, yeah. We change it so we don't have to do quotient because it's so easy to not do quotient. Yeah. Outside in.
But the good news is, it's not gonna be good. Double chance.
It's LN. LN of LN about. Yeah. What? No, because it's not. This is the inside chain part. Yeah. That one was not as hard as y'all were making it.
So,
Yes. Right. We are learning. This one's for Robert. He loves the fraction. What? I didn't hear what y'all said.
the good news is I don't know how to do that.
It's wonderful news. I'm so glad to hear it.
I think I might have done that. Because one over
I would probably write it like that, and I would work from the outside in. Power, inside function, and then if I need to change.
I would, if you don't do it like that, you have to do the first
Yes.
one.
I never do quotient rule unless I have to do quotient rule. Because quotient rule leaves a lot of room for mistakes. Some of you have gotten really good at it though, because you do it all. So got it? All right. I did the power first. And now I'm going to do the inside, right? So how do I find the derivative of this?
One over x times 1 over ln.
That's exactly right. So now let's clean up a little bit. Everything goes on the bottom, it looks like. X, natural log 2. And then I got log base 2 of x. Sorry. No. Multiplication is commutative. Are you feeling okay about any of this? It's a lot of chaining. You will. What, like properties of logs? Is that what you're saying? I think y'all are talking about the expanding and condensing. And we're going to do that tomorrow. Because we're going to use logs to solve equations and in order to do it. Yeah. Although yesterday I can't get the recording. It's saying my like spyware or something won't let me. I emailed Dean, but he hasn't emailed me back. Okay, let's do another. Or just work on your homework. Yes.